Okay, hello everyone. So we have heard that BIM is a big topic in education, so that's what I'm talking about today, as it's actually one of my modules that makes the most fun in teaching. And I'm co-teaching this with my colleague Burcu, Güldür, Erkal, who can't be here today. And I was looking while I prepared this presentation that I have this long title for my paper. So I decided I'm going to combine this a little bit. So it's really about computational BIM, what we are doing in this course. And what do we mean by computational BIM? Is basically that we look at BIM as a data source, and then we use programming to extract that data, and then we can perform reasonings, analysis in terms of energy and structural analysis, and then do some, or also use some AI assistance in doing that. And so before I get into what's I think is currently wrong with BIM education, can you guys give me a hand who is actually teaching a BIM course in this room? Okay, so it's quite some experts here. And I think we still have kind of some ways to go in BIM education. There's still some front-loaded lecture-based teaching. And I think one key issue is that there's limited awareness of data quality and data consistency, and we'll get into that topic. Also, the models are lacking transparency and explainability. There's fragmented performance analysis, and then kind of when we go into automation, this is by most students kind of from the architectural and civil engineering program seen as expert only, so they are not even go into that. And then we also have over-reliance on software defaults and black box workflows. So if you ever have looked at some of the property sets that we just talked about that come with some of the standard objects, instances that you look into the BIM authoring tools, that there are 300 properties by default, and in my view, it doesn't make any sense to actually use 300 default properties. So that's an issue over there. And so the idea that we are trying to tackle this is that we are trying to do this computational BIM, basically getting at the data in the BIM models via APIs, specifically Python APIs. Pretty much all BIM authoring tools have Python APIs now, so we can actually go into those authoring tools, extract the data that we are interested in, and then do our performance analysis. And in this course, we're actually looking at energy and at structural analysis. And the framework we have built around that is actually then tool agnostic, so you can use pretty much any BIM authoring tool that has a Python API, more or less, and yeah, and it's transferable. So how does the course look like? So we basically have 4 phases. We teach foundations at the beginning, then go into the domain theory. Then we have some consultant sessions towards the end of the semester, and then the students are actually presenting their work. So this course is actually happening in the energy efficiency design master program at our university, which we call E2D. So these students know a lot about energy, but not the other topics. And so in detail, we are basically doing a Python crash course within the first 2 weeks of the course. We are talking about BIM theory a little bit, and then we go into the APIs of these BIM authoring tools to tell the students how do they actually get out all the data of these models. And then I do the energy calculation theory part, and with some exercises, and my colleague is doing the structural part of this. And then we go into consultations and get then the final presentations of the students towards the end of the semester. And then in terms of the workflow, as I said a couple of times, we use BIM authoring tools as a starting point. So the students actually in small groups create a relatively simple model in those BIM authoring tools. Then we use the Python API to extract the data. Then we do the structural analysis in terms of going to the OpenSea's open source structural module. And then on the energy side, we are actually going into a relatively simple monthly static energy calculation based on a German standard, which is called DIN 18599. And then for both analysis, we get results, and then we can combine the results to get some insights. And so what I really want to get at is that we want to think about what kind of data do we need to extract out of the BIM model, and more importantly, when and how do we actually define this data that we are interested in, for example, for an energy calculation. So for these monthly energy calculations, we basically have four main topics. We have ventilation losses, transmission losses, solar gains, and internal gains. And for those four topics, we have some properties that we need to get out of the BIM model. For ventilation losses, this is mainly building volume. For transmission losses, this is surface area of all external building elements and their U values. For solar gains, we are looking for the G value of windows, the surface area of the windows, and also the orientation. And then for the internal gains, we are looking at usable floor area in the building. And if you look at this list, this actually doesn't look too complicated, but as usual, the devil is in the details. For example, whenever a building element is external or internal, creates quite a challenge depending on what BIM authoring tool you're having and how to actually extract the data. And then on the structural side, things are a little bit different. So we are more interested in coordinates of the elements and about the connectivity between the structural elements. And we focused on just four elements: the columns, the beams, walls, and slabs here. And we are also thinking about the support conditions and boundary constraints. And so the goal really is to understand that there are different constraints, different requirements for both these two analyses. And we have to think about getting both of these kind of within one script out of our BIM models. And so since there's quite some programming involved, there's no way around the LLM these days, the LLM support. It's actually also really great to use LLMs to dive into the APIs. There's, I think, the Revit, the Python APIs, that's what I wanted to say. Documentation is quite difficult to kind of really get to the things that I'm currently interested in. So LLMs can really help there to find the right objects, the right functions more quickly than it used to be. And then for debugging, it's also very useful, especially since these are students that are kind of not coming directly from a programming background. But nevertheless, the students are responsible for whatever they present. Speaking of the presentation, so here's just some examples of what's coming out of the class. You can see it's a relatively small model here on the left. The monthly energy calculation results. There's some results from the structural analysis. There's some diagrams also on how they structured the code. I'm also encouraged them in this class to kind of use an object-oriented way to structure their scripts. So it's not just one long script with a lot of lines, and you can just see a couple of lines of code here. And then we also did an evaluation of the course, and you can see here the self-assessed confidence in writing software code before the course. And you can see that before the course, the confidence was really low. Again, we're talking about energy efficiency design programs, so there are not a lot of computer science background in there. And then after the course, this actually shifts quite a bit. And I think this is kind of one of my major achievements in this class, that people really acknowledge that programming and scripting Python can help with understanding BIM and getting data out of BIM models. The students have also mentioned a number of lessons learned. So from model quality and data quality, which is also a very important topic in my mind, to the topic that BIM is actually a database, not just a 3D model, that interoperability is key, validation is important, and automation saves time. So I actually have some students that develop the first scripts within my class, and then I can see them over the semesters extending their scripts in these applications to do kind of the stuff that they need to do in other classes and in other projects. And also kind of the thinking, not just doing one specific analysis. I'm usually doing just the energy analysis, but it was very useful to co-teach this with my colleague and also understand what are the requirements for the structural model, for example. Okay, so I put a check here. Just two more quick slides. Future work. So next semester in the winter, we actually want to go open source with this module and using Blender, BIM, and Bonsai. We could also extend more analysis in there. There's also the big topic of including MCP or not. That's a big discussion point we are having at the moment. And we also want to kind of more actively foster the vibe coding in this class because they're doing it anyway. So I think it makes sense to actually give them some more structure there. And I think it also would make sense to compare it to traditional courses. And my last slide, I want to give you a little bit of context of what I'm doing in Augsburg. So this is the CIX module that I'm doing in the E2D master. I'm also doing a little bit in the E2D bachelor. But my main focus, as you can see from this slide, is actually in our new digital program, which is called in German Digitale Baumeister, or digital production and digital design and production. And you can see I have much more time to actually teach the student how to program, how to go into the BIM world, do cloud-based programming. And also we have a really nice project in the fourth semester to let the student actually develop cloud-based platforms by themselves. With that, I'm actually done.